Okay, scientific notation and practice with the calculator. Let's take a look here with the keystrokes. We're using the TI graphing calculators, what you're going to see. For example, and if you're doing this one in particular, you would type in the 2.53 here. Type that in first, 2.53. Then you hit the second button. The second button is usually in the upper left corner, and it's like blue on mine. It could be a different color on yours, but it says second. And that allows you to use the functions that are in blue above the buttons. So 2.53 second, and then the comma button. And the comma is, and this represents the double E because the comma button is right above the 7. So basically you type in 2.53, you do second comma and then the EE, and it's going to look in the calculator like that, 2.53E. Then you type in -4, okay? Then you add, because you're doing the addition here, you do 1.26, second button again in the comma, which puts in the E like that. And then you put in 3 to represent the power on the 10. The E represents the 10 for you. Once you do that in your calculator, you hit equals or enter. I think on mine it says enter. And when you enter, you'll get this number as your answer. Well, this of course is not in the correct number of sig figs, nor is it in scientific notation. So to put it in scientific notation with the correct number of sig figs, first thing you do is look at the place value, how many place values, because this is addition. We're only going to go out 2 decimal places. So I'm going to go ahead and move this over first, 1, 2, 3, 1.26, only going out 2 decimal places, times 10 to the 3rd. So this is the, way to use your calculator without using the caret button. If you use the caret button, you really have to put parentheses around the stuff, or the order of operations do sometimes come out wrong. So you want to make sure that you're using the E, which means times 10, it's doing the exponent for you, because we're going to be using really, really large numbers today due to the fact that we've got Avogadro's number to convert with. So let's look at that. Let's take a look at Avogadro's number. You can practice here real quick, typing these in, get those answers, making sure that you are using your calculator correctly. So actually I'm going to stop for a second and let you have some time to do these real quick, practice with these. All right, so let's check these answers, see how you did. First one, 3 times 10 to the -5. And yes, it's subtraction, so you keep the meter. Second one here, though, you wouldn't really keep this because grams over grams does cancel. So 3 times 10 to the 12th. And then here, kilometers times kilometers, that's an area. So this is going to end up being squared. So 9.6 times 10 to the 8th. Kilometers squared, since this is area. This is like length times width. Hopefully you got down using that, because we're going to need to use it now. So we're going to talk about the mole. And the mole is a unit in chemistry. And it's this magic Avogadro's number. Avogadro is his name. That's what the number was named after. Now, Avogadro didn't actually create the number. He did a lot of gas law experiments and things like that. So he's given a lot of credit in chemistry, but he's not actually the reason why this number is here. They named it after him as sort of a way of giving him credit for all of his chemistry work. 6.02 times 10 to the 23rd. That is quite a power on that. It's a very, very large number, and we're going to listen to the mole song and see why. Now, representative particles. Particles is like the main general term. There are 6.02 times 10 to the 23rd particles in 1 mole of any substance. There are different substances, though. This is where it gets a little confusing. If we're talking about an element off the periodic table, it's atoms. If we're talking about covalent compounds that share electrons like water or carbon dioxide, these guys are called molecules. If we're talking about a charged atom like Na plus, Cl minus, anything with the charge on it, those are ions, of course. And then if we're talking about something that is an ionic compound, which is usually a metal plus a nonmetal, something like NaCl, or what would be another good one here, like K2S, anything where it's a metal, non-metal, these would be called formula units. They're repeating low number ratio units here. So depending upon what type of particle you're talking about designates these labels. But if you see any of these labels, atoms, molecules, ions, or formula units, you know we're talking about Avogadro's number, and you're going to use Avogadro's number. But let's go ahead and take a look and get a good idea as to what we're talking about here in the mole song. Now I know this is totally outdated and the graphics and stuff, but it gets home the point really, really well. And then the Molar Eclipse of the Heart is a pretty funny parody. If you've heard that song, The Total Eclipse of the Heart, it's back from the 80s or whatever. But it's pretty funny. If you want to watch that one, you can. It's a short little like two-minute song video as well. So let's take a look at the mole song. Okay, so now you know, if you've heard of Mole Day, that would be 1023, and the reason why it's called Mole Day in October is because of Avogadro's number, and it's such a big number. And I mean, a mole of water is about a vial, you know, that wide and that high, not very much. Tons of little tiny molecules inside there, more than we can count. But we have to be able to use Avogadro's number and the mole, and there's other things that equal a mole too, which we'll get to later. But we're going to start here with our one-step conversions, our one-step dimensional analysis involving Avogadro's number, which is the particle number. That's where we begin today with the fun dimensional analysis. All right, so we have moles to, or in this case, we're going to do particles to mole. We have our atoms of phosphorus, and we want to find out how many moles that is. Well, like last week, we started with our fences, our T-charts. We're going to continue on with that dimensional analysis way of doing things. Now remember too on the quiz that you have to do dimensional analysis. So you either have to set it up this way or set it up the fraction way in order to get credit. It's not a regular conversion process. It is actually a skill of setting up the labels so that you can cancel them. So that is one of our standards in chemistry, and that's something that you have to know. And we'll later on, when we get to something called stoichiometry, which is a little bit more complicated involving chemical reactions, you're going to want to be able to set it up this way because it's really hard to keep track of the numbers and the switching. So this is our given value, 1.20 times 10 to the 25th atoms of phosphorus. So we need 1.20 times 10 to the 25th, and I would write atoms phosphorus here because I do my unit and my substance. Now, who remembers what we do with our unit at this point? What are we going to do? Where does it go? Does it go up here, or does it go down there? Goes across or goes down? How do we get rid of atoms? We want to put it down here. Yes, we diagonal down the atoms of phosphorus because we want moles of phosphorus. So moles has got to go on the top because we're going to cancel out the atoms. Now, going back to the conversion factor, 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, formula units, whatever. But this case, we're talking about atoms because we're talking about phosphorus only. So 1 mole equals 6.02 times 10 to the 23rd. So that's going to go on the bottom. Now we're going to cancel. So I'm going to switch colors here to cancel, make it a little bit better. So the atoms cancel. See you later. What are we left with? We're left with our moles. Okay. What does this mean in terms of sticking in the calculator? So you want to do this, E25 times 1 over 6.02 E23. And you're going to get your calculator answer. So I always start by writing down the calculator answer and then rounding it to the correct number of significant figures. So I'm going to do here too. So here is my calculator answer. I'm getting 19. Oops. 19.933, whatever. I go over here to my original value and I look at the number here. On all the ones with scientific notation have decimal points in there, so you just start from the left doing the Pacific rule. 1, 2, 3. This one has 3 significant figures. So that means I need 3 significant figures in this answer. So I keep the 1, I keep this 9, and this is my third digit now, the 9. Next to it is a 3. Do I round it up or do I leave it a 9? Leave it. So this is 19.9. Now that's going to be moles of phosphorus. And there is your final answer. This is a one-step conversion, and that's all you would need to do there. Same thing with this one. Let's look here. How many moles? Okay. Particles are 3.87 times 10 to the 21st formula units of aluminum fluoride. So I know here that this is, since it says formula units, I'm going to use Avogadro's number. But before I do that, I need to set up my T-chart. Okay, so given information, upper left corner. Given information, 3.87 times 10 to the 21st. This is going to be formula units. Okay, aluminum fluoride. Like before, we're going to take the formula units and diagonal them down so that they're going to cancel, just like you would with any unit that you wanted to get rid of. And I want moles, so that's going to go here on the top. Moles, ALF3. ALF3 because it's aluminum fluoride. So back to Avogadro's number, 1 mole equals 6.02 times 10 to the 23rd. Now, basically, it's just a division problem. And you don't really have to, like, you can multiply by 1, but you're just going to get the same number on the top. So I kind of skipped that part. And you go ahead and get your calculator answer. So I'm going to go ahead and type this in. Do the E21, 6.02, E23. And here is my calculator answer. I have let me fix this here so I can see where I'm writing. Okay, so I get 0.0064287 is what I'm getting. Okay. If I look over here, though, I only have the 3 significant figures to start with. So the first significant figure here is going to be that 6. Remember, these zeros in the front don't count. So that's 1. This is number 2. This is number 3. Do I round up the 2 or leave it a 2? Round up. So this one, 0.00643. Now, this is quite a long number, so I'm going to change that over to scientific notation. Make it 6.43 times 10, 1, 2, 3 to the negative third moles of ALF3. And that would be my final answer. And that's what we got there. Now we're going to start looking at going from moles to the particles. So here, example number 3, how many molecules of chlorine are equivalent to 4.2 moles of chlorine? It's the same one-step conversion. The difference is what we're starting with is now moles. That's what goes up here in the upper left corner, like so. That's what I'm going to take and diagonal down here. And I'm going to molecules. Now I'm going to tell you an easier way to write molecules because it's a long word. So I do MLCS. MLCS to represent molecules because I can't put mole down because that would be the same as the mole. Molecules and moles are not the same thing. Molecule is a type of particle. So 1 mole, and the only difference here is now the moles on the bottom, the 6.02 times 10 to the 23rd goes on the top next to the molecules because that's a particle number, that's Avogadro's number. And now basically all you have to do is multiply the 2 top numbers, divide it by 1, which is the same number, and then you get your calculator answer. I'd always start with getting that calculator answer. So I end up getting 2.5284 times 10 to the 24th, like so. I look over here though, how many significant figures are in my original number there? Only 2, so how many should I keep in my answer? Over here, I keep the 2, I keep the 5. Do I round up to 5? Or leave it a 5? Because I want to match these 2 numbers over here. So yes, it's just 2.5 times 10 to the 24th molecules of chlorine. So unit substance. In this case, my chemical species or substance is Cl2. Let's do one more. Alrighty here. How many sodium ions are equivalent to 2 moles of sodium? So Na plus is an ion because it has a charge on it. So we know that's also a particle number. That's going to be meaning we need Avogadro's number. Starting with our chart, the 2 moles of Na plus go up here. We take our moles, we diagonal them down. And we want ions on the top. Now there are 6.02 times 10 to the 23rd ions in 1 mole. So all we have to do is once again multiply. Plug in your calculator 2 times 6.02 E23, and you get 1.204 times 10 to the 24th. That's your calculator answer. Now, how many significant figures do we want to keep? Only 1, so we're just going to keep this 1 here. Do we round it up or leave it a 1? We're going to leave it a 1. So it ends up being 1 times 10 to the 24th ions of sodium. To get the correct number of significant figures. Okay, so moles to particles or particles to moles, all of these involve only one-step conversions. This is setting up the dimensional analysis. Now you could also, if you prefer, you don't like the T-chart, you can set it up as fractions. So you could do it this way. It means the same thing. And then you put the 6.02 times 10 to the 23rd on the top of the fraction, the 1 mole on the bottom of the fraction, and same thing, the moles would cancel, and you're still going to get the same answer. Some people prefer to write it like this. Some people like the fraction way. It doesn't matter. Either one of these is considered dimensional analysis or factor label method, and they would be acceptable on a quiz when you're showing your work. right, so taking a look here, reviewing a few rules. When you're adding and subtracting exponents, this is just regular math rules. Like I said, this would be the case that you would not be able to use a calculator. You're going to be able to use your calculator, and if you figured out how to use your double E button from the prior instruction on how to use the TI-85, you're not going to really need to have to do this mentally. But remember, you would want to match the larger exponent here, or you have to convert one to the other in order to add them together. So it's easier, I think, to move it to the larger, or match the larger one. In that case, this would be the 3 here. All I have to do is move this over 1 like that, and then I can add 1 to the exponent and make it a 3. Now that they have the same exponents, I can just simply add the numbers together, and I get 3.2 times 10 to the 3rd. Same thing with subtraction here. I would move this one over 1, 2, and add 2 to the exponent so it matched. Then subtract. And technically, if we're really going by actual rules here, we would only want to round to the 10th spot because of the subtracting rule of significant figures. So we would really want to make this 1.9 times 10 to the 7, and you would drop those two numbers off. Okay? Multiplication, you multiply the numbers and add the exponents. I'm sure you've heard this before. In this case, if I was doing this one, I'd do 4 times 3. That gives me 12. And then I would add my exponents, the 5 plus the minus 1. So you would end up getting this answer, although it's not in scientific notation. You would have to move it over 1 and add to the exponent and get your final answer to get it back in scientific notation. Remember, scientific notation, there's always only one number in front of the decimal point. You keep moving it till one number is in front of the decimal. Division, you would subtract the exponents, divide the value. So I do 6 divided by 3. Then I do 8 minus 5. 8 minus 5. Okay, and I get my answer. 2.0 times 10 to the 3rd. Division rules. All right, I'm not going to have you go through and practice these, although you could practice on your calculator if you need more practice and go through these particular practice problems and see the answer as to what you should get. Now we're going to start with the two-step dimensional analysis, 2 or more fences, or T-charts. All right, how many millimeters are in 40.2 feet? Now, what you're going to be given on the quiz is similar to this, where you're going to be given the conversion factors. You don't have to memorize those. These will be given to you in the problem so you can use them, or above the problem like that, like they are in the pear deck as well. Still going to set up your T-chart like always, and you're going to put your given information in the upper left corner, just like we always do. And I'm going to put my feet down here, okay? So what I need to realize is I need to go from feet to millimeters. Well, if I look at my choices up here, I see feet right here, okay? That's one way to do it. So I think I'm going to use that one. I'm going to show you another way in just a second. But if I put feet here, I can go to meters. And then from meters, I can go to millimeters. So this one's going to take 2 steps. So I go from feet to meters. I put the 3.2 O on the bottom and the 1 on the top next to the meters. But I'm not done yet because I want ultimately in the end millimeters. And I do have this card right here that shows me 1 meter equals 1,000 millimeters. Although technically you should just know that one because it's one of those metric prefix ones. So the feet cancel, but I have to keep going. I have to add another one to my chart. So now the meters go down on the bottom to cancel. And I put the millimeters on the top. And then I insert my conversion numbers. The 1,000 goes on the top next to the milli. The 1 goes on the bottom next to the meter. And the meters will cancel. So then the result is I end up getting my millimeters. So this is the first step. first conversion. This is the second conversion. This one takes 2 steps. Then you multiply everything on the top, you multiply everything on the bottom, and you end up getting your answer. The calculator answer, though, for this one is a little trickier to round, so I'm going to go over it real quick. So the calculator answer was 12,562. So I'll write that up here, 12,562. This is the calculator answer. I can only have 3 significant figures because that's my given measurement value started with. So I'm going to keep the 1. I'm going to keep this 2. Now I look to the 5 for rounding. It's going to round up because of the 6. So 1, 2, 6. But what I have to do with these places is they don't drop off because 126 is way different than 12,600. So I still have to put in the filler zeros. And that keeps my number valid with the correct number of significant digits. Remember why this one only has 3 is because this one starts from the right because there's no decimal spot. This would be the, or decimal point. This is the Atlantic rule. So that is why we would round the answer to 12,600. Yeah, 12,600. So this one has 2 steps in it. You just keep going and you keep canceling and adding more labels in as you're going in order to get to the final result. Now there was a different way you could have set this one up. I'm going to just put it up here. Still put your 42 or 40.2 feet here and you put your feet down here. But if you know off the top of your head that 1 foot equals 12 inches, you could have done that one and then used inches to centimeters. So you could have done inches down here to centimeters on the top. So 1 inch is 2.54. And you could have gone 1 step further and done centimeters to millimeters, and there's 10 millimeters in 1 centimeter. This one would take 3 steps though, 3 conversions to get there. This one only took 2 conversions to get there. Either way though, you'll still get the correct answer. It depends on how you want to build your track. You know, the feet cancel with the feet, the inches cancel with the inches, the centimeters cancel with the centimeters. We still end up with millimeters in the end, which is what we wanted. Depends on how many steps you want to do. And some, you know, people would rather do the top version and do the 3 steps up here because they think that's easier. Just as long as you get there though, that's all that matters. Let's try another one here. I'm about 5.33 feet tall, going to centimeters. Now, that seems like the more reasonable thing. I can still use the feet to meters and meters to centimeters. I believe that one is up here too, right? Where's that one? Yes, it's right here. We can use the 1 meter equals 100 centimeters. So we're going to use that first. Put 5.33 feet in the upper left corner. For the quiz, yes, I will be providing these for you. These you'll get all of the conversion factors. You don't have to memorize them. The only ones you do have to know are like the metric ones. So you should be able to do these ones on your own because of the prefix system. So feet go on the bottom. Now we're going to go to the meter right here. And we insert 3.2 equals 1 meter. The feet cancel. I'm going to keep adding to my track. Now I'm going to diagonal down the meter. And now I'm going to go to centimeter on the top, which I'm going to use this one right here. 100 centimeters equals 1 meter. The 100 goes next to the centa. The 1 goes next to the meter. The meters cancel. And now we just have our lovely centimeter here. Multiply the top, multiply the bottom, and then divide and round to the correct number of sig figs. In this case, we want 3, so we rounded it to 3. Okay, we're going to skip down to problem 8. And if you want to do the other practice problems, just to practice, the answers are on the sheet for you, so you can do the practice and have more examples for this. But we're going to skip down to problem 8 and look at the derived unit. This is a derived unit because we have miles per hour. So 51.2 miles over 1 hour. That is a derived unit. We have a length unit, we have a time unit. And so that actually equates to really a velocity. So a certain length and a certain amount of time is considered to be a velocity. How fast are you going? But we want to know how fast you're going in meters per second. So that's where we're going to convert to meters per second. And we're going to have to convert both units in order to get there, because we want meters over second. So what's that value going to be? Meters per 1 second. Well, I'm going to set it up just like I always do. Information goes on the left, but in this case, we also must include our 1 hour on the bottom. So we have 51.2 miles equals 1 hour on the bottom. Now, like most people like to start with the top unit to convert first. And that's what I'm going to do, is I'm going to start with the top unit, convert it first. All right, diagonal down the mile, okay? And from there, over here, it gave you the conversion factor. We're going to put in our 1609 meters equals 1 mile. So the miles are in and canceled. So now we have meters, that's good. But how do we change hours over? How do we get rid of hours in order to cancel it? Where must it go? If it's already on the bottom, where do we have to put it in order to cancel it? It needs to go where? On the top, very good. So, put that one over here on the top. Hours goes up top. Now, you know that in 1 hour, there are 60 minutes, and then in 1 minute, there are 60 seconds. So if you're really clever and smart, you know that there are 3,600 seconds that equal 1 hour. If you do that mental math. If you don't want to do that mental math, you can add on one more step. But we're going to do the mental math and make it just 2 steps here. So the 1 hour goes on the top, and now it cancels. So we have this one over here canceling with this one over here, and then now we have seconds on the bottom, which is what we want. We want meters on the top, we want seconds on the bottom. So make sure the units match your desired amount, which they do. And you just do the calculation. So multiply, 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 and then divide at the end there. And 3 significant figures to start with, so 3 significant figures in your answer. That's one example. We're going to do another one because I know these ones are a little tougher. All right, so this one, we're going to do liters per hour to milliliters per minute. So this is a volume per time measurement. Just going to start like I normally do and create my T-chart. The liters go in the upper left corner, the 1 hour goes on the bottom. So here's your 1 hour. Doesn't really matter which unit we start with. We can start with the liters or the hours to switch it over. This particular case, I'm just going to start with the liters. I'll put that down here. And if we look, here we go. 1,000 milliliters equals 1 liter. And I wanted to go straight to milli. So I put my 1,000 on the top, my 1 on the bottom. Now I can cancel those liters, which I'm going to do if I can switch my pen color real quick. So liters are going to cancel. Very good. If I keep going on my track though, now I need to put the hours up here to get rid of the hours. And I want minutes, so minutes are going to go on the bottom. 1 hour equals 60 minutes. I have it all set up and I'm ready to go. The hours are going to cancel with the hours. I have milliliters per minute, which is what I want. So 24.9 times 1,000 times 1 over 1 times 1 times 60. Really, you don't have to put the ones in there, but you calculate this, you get exactly 415, which works out nicely because here we have 3 significant figures. So that's why we have 3 significant figures in our answer. Do not forget your unit. Unit is important. We have no naked numbers in science. All of the numbers have a measurement. Okay? Have a unit to go with it because it is a measurement, I should say. So that is another example of a derived unit conversion, which you will see one derived unit problem. You'll see one that's a one-stepper and then one that's probably a two-stepper. Maybe a metric prefix question, and one conversion of scientific notation, either in your answer as you're calculating or in a separate problem. So it's not even going to be more than 5 particular questions on this short quiz.